What is the difference between a flat slab and post-tensioned slab? Hi, I'm a civil engineer. I hope you benefit from our channel. To watch more, please subscribe and ring the bell. And now, let's get the right answer. Flat slab is a full concrete slab reinforced by conventional steel rebars and supported directly by concrete column. Petty slab is also a full concrete slab but reinforced by combination of conventional steel bars and high-strength steel tendon, which are consequently subjected to tension after the concrete has set. We have two types of cables, bonded and unbonded. To execute a flat slab, first we place the bottom and top mesh reinforcement with additional rebar required, then we pour the concrete. While the petty slab has a long procedure in comparison with the flat slab. First we place the bottom mesh reinforcement, second we install the petty cables, next we place the top mesh with all additional rebar required, then we pour the concrete. When the concrete reaches the desired strength, the tendons are pulled by special hydraulic jack. Finally, we inject the cement in the ducts if we use bonded tendons. This final phase is neglected when using unbonded tendons. In petty slab, the bending moment provoked by gravity loads is added to hyperstatic moment caused by post-tensioning forces in continuous slabs. This moment has a positive value and a little effect on the results. The bending moment at ultimate in flat slab is totally covered by conventional steel rebar, while in petty slab this moment is covered by high tensile steel tendon that's called active reinforcement, and also it can be covered by conventional steel rebar if needed, that's called passive reinforcement. Post-tensioning tendons are virtually replaced in the slab by set of forces they exert on it. First, compression along the slab perimeter that resists tensile stresses, and in addition upward forces in the span and downward forces over the supports that decrease the tension and compression stresses due to applied loads. According to ACI code, the compression stress in concrete for a pre-stressed flexural members should not exceed 0.6 compression stress at surface, and the tension stress should be lesser or equal to 0.5 square root of compression stress for two-way systems, while for a flat slab no limits are existed for stresses at surface. Deflection control is a center consideration in serviceability of floor systems. The deflection is inversely proportional with the moment of inertia, so more the inertia is bigger, more we obtain a smaller deflection. The reduction in flexural stiffness due to cracking in a flat slab is accounted for by substituting the gross moment of inertia with a reduced effective one, while in petty slab the calculation of deflection is based on the gross moment of inertia because no cracks exist in the concrete. In addition, the uplift due to pre-stressing forces counteract the deflection due to gravity loads and minimize it. We have here a slab with double span 8 meters, and it will support residential load. When a flat slab is used, its minimum thickness is 30 cm to meet all design requirements, especially the deflection that can be the most critical criteria. On the other hand, the thickness of petty slab depends on the amount of tendons used in it. If the amount of tendons is 2.6 kg per meter square, the minimum thickness of petty slab is 28 cm. If we increase this amount to 3.5 kg per meter square, the thickness of slab decreases to 25 cm, and it will be 23 and 20 cm if the amount of tendons is increased to 4.4 and 6.3 kg per meter square respectively. With using petty slab instead of flat slab, we have reduction in concrete volume about 20%. It may change according to the amount of tendon used in the slab. Therefore, this reduction reduces the size of columns and foundations and improves the seismic behavior. The amount of conventional steel rebar can be dispensable in petty slab when bonded tendons are used with pre-compression greater than 0.7 MPa in the whole slab, but generally 65 kg per meter cube is the steel ratio used in a petty slab, while it's about 140 kg per meter cube in a flat one. So we have reduction about 50% in conventional steel rebar when using petty slab. The price of 1 ton petty steel is almost the same as 1 ton conventional steel rebar, but with its accessories, its price becomes twice that of conventional steel. The cost of installation, stressing and grouting 1 ton of steel tendons by a company, plus its own price with accessories, equal almost 5 times the price of 1 ton conventional steel rebar. The using of petty slab in underground floors impose some solutions to mitigate the cracks caused by the restraint of shortening, as delay strip joints and release connection. Sometimes these solutions can be annoying to developers. Petty slabs need expert laborers or a special company to install stress and inject the steel cables. Generally, the modification in flat slab is more easy and practical. In fact, when bonded tendon is severed, the free end will become detensioned, but after a short transmission length, the full tendon force will be effective, while when unbonded tendon is severed, the pre-stressing force will be lost for the full length of tendon. Many differences exist between PT and flat slab, and according to material prices, possibility of modification, span length, seismic zone, and the location of floor, we can decide which slab is the best solution.